All right, it's time to get ready for our Unit 9 test. And for all these, we're going to find the domain, the VA, the HA, SA, and the holes. So for this one, we're always going to start with the HA. And for the HA, we're going to look at the degrees. So let me make sure my pen's good. On number 1, the degree on top is 1, because it's 6x to the first, and the degree on bottom is also 1. They're equal. And when they're equal, we look at the leading coefficient. So y equals 6 over 1. So my HA is y equals 6. Since there's an HA, that means there's no SA. You can't have both an HA and an SA. Horizontal asymptote, slant asymptote. I'm going to factor if possible. Nothing factors, so that means there's no holes because nothing cancels out. Set the bottom equal to 0 and solve. And that's your VA, your vertical asymptote. And then your domain is going to be all real numbers, but x cannot be wherever the VA and the holes are. So x cannot be 4. Number 2, same thing. For my HA, the degree on top is 0, degree on bottom is 1. 0 is less than 1, so my HA is going to be y equals 0, which means there's no SA, nothing cancels. If I set x equals 0, that's my VA, all real numbers, x cannot be 0. Number 3, degree on top is 2, degree on bottom is 1, 2 is greater than 1, which means that there is no HA. So there will be a slant asymptote, so I'm going to do the synthetic division, so I'm going to set that equal to 0 and put that in my box. List all my coefficients, so I have 5, there's no x term, so 0 and 1. We'll drop down to 5. We'll multiply, we'll add, and we'll multiply, and we'll add. That number doesn't matter on this one. And so on this one right here, our slant asymptote is 5x minus 15. And then for the holes, nothing cancels, because there's nothing factors on top. X equals negative 3, and all real numbers, but x cannot be negative 3. Number 4, the degree on top is 2, degree on bottom, is also 2. These are equal, so we're going to look at the leading coefficients, 1 over 2, so y equals 1/2. There is no SA. On this one, factoring, on top that's difference of squares, so x plus 2, x minus 2. On bottom, I've got negative 12 and positive 1, which is going to be 4 and negative 3. We're dividing by 2, so we get x plus 2 and 2x minus 3. So those cancel out, which creates a hole where x equals negative 2. And then to find the y value of that hole, we're going to plug in negative 2 into what's left over. So negative 2 minus 2 over 2 times negative 2 minus 3. So that has to be negative 4 on top. That has to be negative 4 minus 3 is negative 7, so 4 over 7. For my VA, whatever's left over on bottom, I set equal to 0. So if I set 2x minus 3, we're kind of putting work everywhere, is equal to 0. We're going to add 3 over and then divide by 2. And so x equals 3/2. So my domain's all real numbers, but x cannot be 3/2 or negative 2. All right, now we're going to get into the graphing on top of what we were just doing. And so for the first one, my degree on top is 1, degree on bottom is 2, so y equals 0. I've got x minus 1 over x squared minus 1 becomes x plus 1, x minus 1. So x minus 1's cancel out, which means there's going to be a hole where x equals 1. To find the y value, we'll plug it in, so 1 over 1 plus 1, which is 1/2. And then if I set that equal to 0, x equals negative 1, all real numbers, but x cannot be negative 1 or positive 1, plus or minus 1. As far as the graphing goes, I've got a VA at x equals negative 1. I've got an HA at y equals 0. And I've got a hole at 1, 1/2. And for the rest of the graph, I'm going to go to the calculator. So in my y equals, I'm going to do the fraction, x minus 1 on top. x squared minus 1 on bottom. So that's what the graph's going to look like. And I'll just pick a couple points on either side of -1, because that's my asymptote. So on the left side, we'll do -2, -1, -3, -1/2. And then we're just getting closer and closer to that asymptote. So there we go. And then on the right side, I've got 0, 1. And I already have my hole right there. And then 2, 1/3. And there's the other graph. All right. For the next one, the degree on top is 1, degree on bottom is 1. And so I'll write that down. They're equal to each other, so we look at the leading coefficient. So y equals 2. So I'll go ahead and draw that horizontal asymptote. There is no slant asymptote. Nothing cancels out, no holes. If I set the bottom equal to 0, x equals -3, so all real numbers, but x cannot be -3. 1, 2, 3. Then I'll go to my calculator again to get some coordinates. So I've got 2x minus 1 on top and x plus 3 on bottom. And so there's what it's going to look like. And now we'll go into the table to pick a few points on either side of that -3. So I've got -4, 9, 1, 2, 3, 4, 9. -5, 11 halves. 11 divided by 2 would be 5.5. So 1, 2, 3, 4, 5.5. And then 13 divided by 3, that goes in 4 1/3. So 1, 2, 3, 4. And so there's the left side of my graph. And now we'll do the right side as well. -2, -5. 2, 3, 4, 5. -1, -3 halves. And 0, -1/3. All right, number 7. Again, the degrees are equal. Degree on top is 1, degree on bottom is 1. They're equivalent to each other. And so I look at the leading coefficients. And so y equals -2. No essay on this one. Nothing cancels out. X equals -2. All real numbers, x cannot be -2. So again, we'll go into our calculator. On top, we've got -2. On bottom, -2x. On bottom, I've got x plus 2. So I'll go on either side of my asymptote of -2 and plot a few points. And so on the left-hand side, I've got -3, -6. 2, 3, 4, 5, 6. -4, -4. 1, 2, 3, 4. And -10 would just be 3 1/3. 1, 2, 3 1/3. Now on the other side, I've got -1, 2, 0, 0, and 1, -2/3. This one's in transformation form. There aren't x's on top and bottom, so we can look at this using our transformations. That negative is going to reflect over the x-axis. X plus 2 is going to go left 2 and then up 3. And so left 2 is going to be my vertical asymptote. Up 3, 1, 2, 3 is going to be my horizontal asymptote. This one is going to reflect, and we'll use those normal base points that we did in class, where if I go right 1/2, I go up 2, right 1 is up 1, and right 2 is up 1/2. Those are all from the intersection of the asymptotes. However, on this one, we have the reflection, which means instead of going up, we're now going to go down. And so because we're multiplying by that negative, we're going to go down 2, we're going to go down 1, and we're going to go down 1/2. So from the intersection of asymptotes, we'll go right 1/2 and down 2, right 1 and down 1, right 2 and down a half. Same thing on the other side, just opposite. Left a half, up 2, left 1, up 1, left 2, up a half. And if you were to graph it in your calculator, it should look like this right here. All right, number 9. On this one, we're back to x's on top and bottom. And so my degree on top is 2, on bottom it's 1, which means there is no HA, which does mean we're gonna have to do the division. So if I set the bottom equal to 0, I get x equals 1. And then I put that in my box, 1, 2, -4. I drop down the 1 and multiply. I add, I multiply, I add. I don't care about the remainder, y equals x plus 3. Nothing cancels out because there's nothing that factors, and so all real numbers, but x cannot be 1. So we're gonna have a VA at x equals 1. The SA is x plus 3, which means our y-intercept is 3, 1, 2, 3, and our slope is just 1. So we're going up 1 over 1 every time. So there's my slant asymptotes. And then now we'll just go under our calculator to see what this is going to look like. So I've got x squared plus 2x minus 4 over x minus 1. So there's what it's going to look like. Another thing you can do if you wanted to see the asymptote, there's the slant asymptotes y equals x plus 3. There's how you can see it's getting close to that red line. It even looks like it's touching it sometimes, but it actually never touches it. It gets really, really close, but doesn't quite touch it. And then our asymptote is 1, so I'm going to go either side of that error of 1. So I've got 0, 4, 1, 2, 3, 4. -1 is 5 halves, which would be 2 1/2, 1, 2 1/2. And then -2 is 4 thirds, which is 1 1/3, so right up there. And so we're gonna get closer and closer to that asymptote, but not quite touch. And then same thing on that one. And for the other side, I've got 2, 4, 3, 11 halves, which would be 5 1/2, so 4, 5 1/2. And 20 thirds. If you divide 20 by 3, 3 goes into 26 times with 2 left over. So that's 6 and 2/3. 1, 2, 3, 4, 5, 6 and 2/3. So we're gonna get closer and closer to that asymptote, but not touch it. And then same thing with the vertical asymptote. This one we don't have x on top and bottom, so this one goes back to the transformations, where this is going to go right 1, up 3, and it's going to be a vertical stretch by 2. And so my VA is going to be x equals 1. My HA is going to be y equals 3. There is no SA, no holes. My domain's all real numbers, but x cannot be 1. And so we're going to have that VA at x equals 1. Have that HA at y equals 3, 1, 2, 3. And on this one, it's normal. However, if I were to do my base points again, on this one, we're multiplying by a stretch of 2 on the y component. And so we're going to go up 4, we're going to go up 2, and we're going to go up 1, all from the asymptote. And so we're going to go right 1/2 and up 4, 1, 2, 3, 4, right 1 and up 2, right 2 and up 1. And then same thing on the left side, right 1/2 and down 4, 1, 2, 3, 4, 1, 2, and 1. Again, this one doesn't have an x on top and bottom, so we're doing our transformations. And so we're going left 4, down 2, so x equals -4, y equals -2. All real numbers, but x cannot be -4, no SA, no holes. This one is going to reflect and stretch. So on our table, when we go right 1/2, instead of going up 2, we're going to go down 6. because 2 times 3 is 6. And when I go right 1, instead of going up 1, we're going to go down 3. And when I go right 2, instead of going up 1/2, we're going to go down 3/2. So we've got x equals -4, 1, 2, 3, 4. Y equals -2, 1, 2. So we go right 1/2 and down 6. 1, 2, 3, 4, 5, 6. And then 1, 2, 3. And then 1.5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 1.5. So what is the equation of the parent function? The parent function is y equals 1 over x. Vertical asymptote, x equals 0. Horizontal asymptote, y equals 0. Domain, all real numbers, x cannot be 0. All real numbers, y cannot be 0. Now we're getting into the teamwork problems. It takes Mario 5 hours to complete a task. It takes Luigi 3 hours to complete the same task. How long will it take to complete the same task if they work together? So Mario is going to be 1 over 5 for the one job. It takes 5 hours. Luigi for the one job takes 3 hours. And we want to know how long does it take them to do it together. So to get my common denominator, I need to get up to 15 and x. And so we're going to multiply this one by 3x. Multiply this one by 5x and this one by 15. I don't need the denominators anymore, so 3x plus 5x is equal to 15. That's 8x equals 15. X equals 15 over 8 hours. Together, it should take less than it takes either one individually. 15 divided by 8 would be a little bit under 2, which is less than both of them, each of them separately. It should take less time when they work together. If you're getting more time, you're not doing something right. All right, Chandler can mow his yard in 4 hours. When Monica helps, it takes them 3 hours to mow the yard. How long would it take Monica to mow by herself? And so Chandler is going to be 1 over 4. Monica, we don't know, but together it takes them 3 hours. So 4 and 3, we need to get up to 12. And we have the x, so I need 3x. I need 12, and I need 4x. And so I'll come over here. 3x plus 12 is equal to 4x. I'll move the x's over by subtracting. And so when I subtract 3 from 4, that gets 1x. So x equals 12 hours. So if Monica were to mow by herself, according to this problem, it would take about 12 hours for her. And that completes our review. If you have any questions, let me know.